Good afternoon, everyone. Welcome to today's SME's Technical Community and Aerodef Manufacturing Satellite Session webinar. Today's webinar, How is the Department of Defense utilizing cold spray technologies? You'll hear about the ongoing and planned DoD cold spray programs and how the DoD plans to broaden cold spray applications and benefits for Aerodef manufacturers. I'm Carl Mitroff, Aerodef Manufacturing Conference Manager, and thank you for joining us this afternoon. Before we get going, I have just a few housekeeping items that I'd like to share. You'll recognize right away that your microphones have been automatically muted. If you have questions regarding the functionality of the webinar platform, please use the chat feature. If you have questions that you would like to pose to our guest speakers this afternoon, submit them using the Q&A box in the platform. We'll be monitoring both. In the event of any technical glitches, please note that we will be recording this presentation and it will become available on our Aerodef webpage about 24 hours after. Before we get going, I'd like to quickly introduce and thank Mr. Gino Spinas. Gino is the Director, Manufacturing Engineering for the National Center for Defense Manufacturing and Machining. He led the OSD Mantech DoD-wide cold spray technology roadmap project that you'll hear more about this afternoon. Gino's input and guidance played a major role in development of today's webinar, and I thank him for his time and commitment. Hosting today's webinar is Mr. Keith DeVries. Keith is responsible for program management to OSD's Joint Service Manufacturing Technology Program, providing investment into industry and government partners to transition prototype technologies into manufacturing scale sufficient to address fielding demands and technical advantages for our warfighters. Thank you, Keith and Gino, for your time. Thank you, Keith, for moderating today's webinar. I'll kick it off to you.
Fantastic. Thank you, Carl. I do appreciate the opportunity to be in the presence of some excellent experts in the field of cold spray technology. I look forward to the remarks from all of our presenters, Bill Baker, Isaac Nalt, Jeff Campbell, and Fred Lancaster as we progress through the afternoon. Before we dive too deeply into the heavy meat of their presentations of where they and their services are taking cold spray, I wanted to spend just a few minutes in stage setting for where OSD's Mantech program fits into the world of cold spray, and then a few moments describing the roadmap activities that really brought us all together. As a housekeeping item of my own, Carl mentioned that we will be doing Q&A through the Q&A chat box. I do want to point out that we will save all of our questions and answers for the end of the presentation after all of our presenters have completed. So if you have a question that is targeted to one of the presenters, please do identify that in your question so that we can make sure that we address those specifically as necessary. So next slide, please. And next slide again. I am Keith DeVries. As Carl mentioned, I'm the program manager for manufacturing science and technology that is within the DoD manufacturing technology program housed within OUSD, Office of Undersecretary of Defense for Research and Engineering. Next slide, please. Just a few comments on manufacturing technology as a whole. And then I'll offer some thoughts on cold spray and the roadmap that we developed in the past 2 years. So why does Mantech exist is a question that I'm often posed in conferences and conversations. And we understand very quickly when we as DoD look to field our systems, our platforms, our devices, that manufacturing excellence is a critical parameter for DoD technology dominance and force projection. So without Mantech, we're not able to transform our emerging technologies, those items where we've made 1 to 10 to 15 prototypes into something that can be manufactured at scale to be a disruptive capability. Mantech is targeted specifically at addressing those manufacturing challenges that fit beyond the risk of industry. And without manufacturing and the technology investments in process development, we risk cost overruns due to low yield or insufficient throughput for our immature technologies as those are building out to scale. And one of the taglines in our office is, simply put, any technology, any emerging technology is fine, but if you can't make it, you just don't have it in the hands of your warfighters. So we are happy to be a part of the broader Mantech community. There are Mantech offices in all of the services, Army, Navy, Air Force, the agencies, Defense Logistics Agency and Missile Defense Agency, and those are represented in the center of the current slide. And then the OSD office rounds out at the sixth position in that lineup. And then to execute the projects that we identify in our vast and diverse portfolios, we engage not only across DoD and all of the R&D enterprise in all of the service labs, but then we also have connections across all of all of government, including the NASA and forestry and beyond. We have really a vast network that we tap into when we are executing our programs. Lastly, I want to point out that within OSD Mantech, we have two principal arms of investment. One is the traditional technology investment program, which I shepherd as the MSTP program manager. But then we also have 9 manufacturing innovation institutes focusing on developing a technology ecosystem that is of critical importance to DoD, but is also dual purposed with commercial benefit. One of those manufacturing innovation institutes of principal importance for today is America Makes, and they helped us in developing a roadmap for cold spray. And if we go to the next slide, we can talk a little bit more about cold spray and how that roadmap came to be. So I'm sure everybody is well aware of what cold spray is, but in case anyone isn't, cold spray in its essence is taking a metal powder, and there is some heating, so it's not truly cold spray, but the heating is certainly not enough to melt any of the powder. And then we accelerate the powder to supersonic speeds, and in so doing are able to spray that powder onto a metal substrate. As that powder impacts and impinges, it deforms and work hardens on impact, and this gives us the capability to build back areas that have been worn or corroded or otherwise provide an insufficient part for our platforms and systems. So with that as context, the Office of Secretary of Defense, and leveraging the development work within DoD over the last 15 to 20 years in Mantech or in cold spray, we commissioned a roadmap to chart the successes achieved, codify the current activities, and to capture upcoming challenges in the adoption of cold spray as a commonly deployed industrial capability. The road mapping team, led by America Make and the Barnes Group, the Barnes Global Advisors, they coordinated a series of reviews and workshops focused on DoD applications and aspirations for cold spray to construct the was, the is, and the will be of usage. And the roadmap itself is available for DoD agencies upon request. Roadmap has informed the Joint Defense Manufacturing Council on opportunities to strengthen DoD's awareness of cold spray capabilities and to address barriers to implementation. In the process, the DoD community advocating cold spray has come together to actively share lessons learned, leverage common practices, and foster a coordinated approach to new cold spray applications. Next slide, please. Shown here is a subset of the priorities identified by the team in the road mapping sessions. The JDMC has commissioned work in several of these areas since the roadmap was published, with the express intent to expand understanding and adoption of cold spray as a cost, and more importantly, time savings approach to sustaining our vehicles, our vessels, our platforms, and our systems for warfighter use. The panel members gathered today will be expanding on their individual service efforts to address roadmap challenges and further their warfighting capabilities by developing cold spray as an industrial process. Next slide, please. Our first presenter is Bill Baker. He is from Marine Corps Logistics Command in the Maintenance Management Center, where he is the lead engineer for the MMC and provides engineering guidance, technical support, and technology insertion for the workload executed through MMC and their commercial sources. Mr. Baker, it is over to you.
All right, thanks, Keith. Hey, yeah, so this is Bill Baker. I just want to kind of give you an overview of where the Marine Corps is going as related to cold spray. So we can go to the next slide, please. Okay, one more. All right. So a little bit about us. So Marine Depot Maintenance Command is our official title for our Marine Corps depot. There is only one Marine Corps depot, but we have two locations. One is in Albany, Georgia, and the other is in Barstow, California. Similar capabilities at each of our plants, and they work the same types of equipment. We basically rebuild all types of ground combat equipment. So if you think about armored personnel carriers, light armored vehicles, engineering equipment like forklifts and bulldozers, we work trailers, trucks, Humvees, anything you can think of on the ground side, even rifles. So when we talk about cold spray applications, we're talking about supporting this depot maintenance. So we completely repair or rebuild these ground combat systems based on our customers' requirements. And during that maintenance operation, we're going to have things that need repair, of course. And then we bring them back up to basically condition code A, which is like new. Next slide. So I just want to kind of give you an overview of some of our use cases. So the Marine Corps is kind of just getting started on the cold spray application. We actually talked about cold spray. I went through my old notes with one of my old jobs, and in 2002 we actually looked at cold spray applications, but we just didn't have the funding and didn't have the drive or the roadmap that we have today. So we're really excited to finally be pushing cold spray across the Marine Corps, and so we're starting to get some of these applications. So the first one you see up there is our hydrostatic steering unit head. This is one that the Applied Research Lab at Penn State is helping us develop a repair for. This is a pump housing that has some significant wear on it. It's expensive and it's hard to get. So they actually developed some new spray techniques and actually some innovative masking techniques also, because you see all those little holes are oil passages. So they're able to come up with ways to get the coating to go to the edge of that oil passage, but still provide adequate, make sure that the oil passage wasn't blocked. So we're currently waiting on approval to use that. We're going to do some real world testing. Also, that impeller bore is another one that we're working on right now with Penn State. And actually the Army Research Lab is helping us with that one also. So inside that impeller, it's also expensive and hard to get. And that aluminum impeller wears over time and also has some significant corrosion issues. So they're helping us develop a repair for the inside of that bore. They got a mock-up complete right now. Once that's complete, we're going to spray an actual impeller and do some testing on that. So those in the Marine Corps are the only two applications that we're currently working at this time. So we're just really getting started, the first two. Down at the bottom of the screen, you see some potential future applications. So every piece of ground combat equipment that we have has a shaft on it, and all those shafts have seals or O-rings that keep the oil passages sealed. And those O-rings and seals cause damage and pitting over time. So we're hoping that we can actually repair these yokes and the mating housing so we can bring these pieces of gear back operational. We're also kind of pie in the sky is the one on the right there at the lower right is corrosion and pitting on our hulls. Every single hull I've ever seen. So I used to be a production engineer, and I'd be on the shop floor every day, and every single one of our vehicles have some type of corrosion on it. So to be able to repair that wear or corrosion rather, on both steel and aluminum is an interest to us for sure. Next slide. So just to update on our cold sprayed equipment. So like I mentioned, we have 2 plants. Our Albany plant has already have our cold spray equipment awarded, and this is the specifications for it right here. It's going to be completed by July of this year. It's going to be installed by the end of June, and then we're going to do some training, and then we'll be fully operational. This is what we call a semi-portable unit. For the Marine Corps, we wanted something semi-portable so that if we had to move it, if we needed to take it to a vehicle instead of bringing the part to it, so we made sure that it was able to reposition, move it to a different building, move it to a different vehicle, move it outside, whatever we had to do. We wanted to be definitely flexible. Our Barstow plant has the similar system on their budget for FY22, and they actually have some low pressure systems that they've had for probably about 10 years. But for the Marine Corps, we don't have a whole lot of applicants for those applications for those low pressure systems. So we're going to these high pressure systems that you see here. All right, next slide. So just to wrap things up, we're just looking to repair all types of components and parts as part of our ground combat depot maintenance. Our focus right now is on depot maintenance, but the fleet has the same type of applications also. They're already calling us on some particular issues. So as we get smarter, better, we're going to take our lessons learned to the fleet too. We can also repair their parts at the depot and send them back to them. We are having, as part of our roadblocks, we're having some issues with approval. We only have 2 parts so far, but getting approval for those can be difficult. So we've been working with our OSD team and our other members of the Navy and the Army to come up with some better ideas on how to get these cold spray applications approved quickly. And I think that's going to go well. We're going to follow the same process we have for additive manufacturing, so we think that's going to help us make the decisions a little bit faster. And like Keith said, we're working with the Navy and other DoD organizations to really push this technology. Because we are part of the Department of the Navy, we're working directly with them every day on cold spray applications and trying to steal as much from them as we can because they're doing great work. And that's all I have for today. Thank you.
Thank you so very much, Bill. I'd correct you only minorly. We're not stealing from the Navy. We're leveraging the Navy.
Yes, sir. I like to call it stealing. I'm from South Georgia. Thank you.
It's a very honest way of approaching it. Just a reminder of the programming note for the attendees. We will address questions via the chat window or the Q&A window specifically at the end of our 4 presentations. So if you have specific questions for Bill Baker, please do drop those in the Q&A session with a reference to either U.S. Marine Corps or to Bill specifically himself, and we will make sure to address that at the wrap-up Q&A session. Moving from the Marine Corps and their expeditionary mission, I want to then transition to the Army's deployment of cold spray technology, and we have Dr. Isaac Nalt from Army Research Laboratory at Aberdeen Proving Grounds. He is a lead expert in the field of cold spray additive manufacturing, and he has been focusing on robotic path optimization for near net shape fabrication and high temperature materials for extreme environments. ARL has been a pioneer in the field of cold spray for DoD applications. They have stood up a cold spray center over the last decade or more. And so I really do look forward to hearing what Dr. Nalt has to offer us as far as the Army's plans and deployments for cold spray. So over to you, Isaac.
All right, thank you, Keith. Yeah, so as Keith mentioned, we've really been kind of a leader in the DoD community at developing cold spray technology. And over the years, we've been doing a lot to support not only the Army, but other branches of the DoD. So today I will be going over some of the ways that we're utilizing cold spray technology, and I'm going to try to tie those into the DoD cold spray roadmap. So next slide, please. All right, so first is agile cold spray systems. These are systems that are designed to have most of the features of a cold spray booth wrapped up in a smaller transportable package. So we have two systems that are planned for demonstration in the next 6 months. One is the trailer mounted system, and this is something that's really designed more for outdoor operation. It can be hauled by any Army light utility vehicle, and it comes with a deployable collaborative robot arm. The other is what we call the mobile hospital, and contrary to the name, this isn't a hospital for people, but rather a hospital for parts. And that is a system that is contained within 2 shipping containers. And that system is designed for parts with slightly higher criticality than what you might repair using the trailer mounted system. Both of these systems are going to be powered by diesel power generators and come with compressors for spraying with compressed air. But if you have bottled helium or nitrogen, they can run on those gases as well. So these systems kind of tie into the DoD cold spray roadmap through priority number 4, capability stand up, and priority number 5, non-booth cold spray. Next slide. We're using cold spray as a means to additively manufacture refractory alloys for various applications in extreme conditions. Some of the materials that we can cold spray are shown in this table. Niobium and tantalum alloys cold spray very well. You can also cold spray nickel and nickel alloys with consumable nozzles and carbide blends. And there's a lot that goes into additively manufacturing parts with cold spray. And so there's a lot of development going on there and a lot of tie-ins with the cold spray roadmap. So one of those tie-ins is we're developing methods for processing deposits after cold spraying to enhance the material properties. And that ties into priority number 7, process enhancements. We've also developed software for developing tool paths to manufacture parts to near net shape, and that ties in with priority 8, engineering for structural and critical applications, and priority 12, part manufacture. Next slide. We have developed and commercialized coatings and powders rather for wear and impact protection. These are based on blends of carbide and metal, and we call them WIP powders, where WIP stands for wear and impact protection. We have commercialized 3 primary varieties. You have WIP C1 and WIP C2, which are a little bit cheaper to manufacture and can be sprayed with nitrogen. WIP W1 has better material properties, so that's really for higher criticality applications, but has to be sprayed with helium, so it's a bit more expensive. And these coatings for wear and impact protection tie into the roadmap through priority 2, which is steel non-structural repair, because this is an ideal material candidate for repairing high-strength steels, and also priority 9, corrosion and wear coatings, and priority 10, environmental compliance and safety, because this is also an ideal material for replacing toxic chrome coatings. Next slide. We're using cold spray for structural repair, and structural repair is defined as a situation in which you would expect that the cold spray deposit will bear a significant amount of load. So we're talking about more than just coating here. And this ties in with the roadmap for priority 8, which is engineering for structural and critical applications. So much of the work we've done in structural repair has been focused on aluminum alloys. We've developed processing conditions and best practices for structural repair of aluminum. We've also commercialized powders that are pre-processed, such that when they are properly sprayed, they will have ideal material properties for structural repair in the as sprayed condition. So there's no further processing required, which is critical for repair applications. And another more recent thing that I wanted to highlight is we have demonstrated the capability to predict areas where defects may be likely to occur based on the part geometry and toolpath geometry. So in this example, we looked at divot repair coupons, which are basically simulating a blend out of damage and filling in with cold spray. And what we showed is that we could predict an area where there would be a higher likelihood of interlayer delamination. And that area was consistent with where we were seeing the failure of these coupons, consistent with the predicted location. So we see this as a way to mitigate defects through the generation of tool paths going forward. Next slide, please. And finally, we're using cold spray for inner diameter coatings. And this has been made possible thanks to the design of miniature nozzles. And we've designed nozzles that are actually capable of fitting in inner diameters as small as 2 inches. So we've designed miniature nozzles for both whip materials and aluminum alloys. The aluminum alloys are a little trickier because they require a consumable high temperature polymer nozzle. So that's a little bit trickier, but we have developed that at this point. And these all tie into the roadmap through Priority 6 engineering and Priority 7 process enhancements, because we really had to understand the relationship between nozzle design and cold spray coating quality in order to design these nozzles. And so that's what I have for today. Thank you.
Thank you very much, Isaac. It's always exciting to see where the Army is taking on new applications for cold spray and really manufacturers in cases like the nozzle design to give additional tools for our operators out in the field. So thank you very much for that Army perspective. Next in our lineup is Jeff Campbell. He is the cold spray project manager for NAVC. So NAVC is going to be represented, or sorry, the Navy will be represented twice today. There is the NAVC component, which is the surface and undersea vessels. And then we will have NAVAIR represented because their use case for many technologies, and cold spray is no exception, is different. So we will hear later from NAVAIR. But NAVC is our first Navy representative, and that is Jeff Campbell. And Jeff is the manager for the development and fielding of cold spray technology across the NAVC organic and defense industrial base. Jeff has been instrumental in instituting cold spray as a service, as a new model for how we develop and deploy cold spray for the organic industrial base. So given that, I would love to turn it over to Jeff to hear where NAVC is taking cold spray. Over to you.
Thank you, Keith, and thank you for allowing me the opportunity to present today. Next slide, please. So, like Keith said, the NAVC portion of the Navy is surface vessels and subsurface vessels. I'm going to take a little different approach. I'm going to talk about the cold spray program and vision as opposed to a lot of the technical portions of it. So next slide, please. So one of the tools I use is the McKinsey 3-horizon model. And the first horizon is adopt, second horizon is adapt, and the third horizon is design. So in the adopt phase, one of our projects is the initial fielding of cold spray technology into the naval shipyards. So in 2019, we decided that cold spray is far enough along that we can start implementing the technology in the naval shipyards. So the 4 naval shipyards being Pearl Harbor, Puget Sound Naval Shipyard, Portsmouth, New Hampshire Shipyard, and Norfolk Naval Shipyard, as well as one of our forward SRFs, surface repair facilities in Japan. So 5 different setups, and the initial fielding of the technology is booth application. So the initial fielding will be bring your part to the booth and have the cold spray repair done at a booth on the shipyard premises. So part of being able to interchange the shareable QSPs, which are the recipes for cold spray repairs, we decided we'd have all the same equipment, and that way, if one of the shipyards designs one of these qualified spray procedures or QSPs, it can be shared, and that saves a lot of time in developing and testing. And we have very similar components, so we're in the process of working with the road mapping crew that did the cold spray road mapping and adapting a program called Jamex to be that repository for the cold spray QSPs. So one of the other things we looked at was not everything can be taken off of a ship or a submarine to be repaired. So the Navy had a RIF and a SBIR project to develop the Raptor, which is the portable cold spray machine that Bill Baker had referenced, and it's the one all the way on the bottom on the right. So that machine you can roll to a lathe or in shop or someplace that has quite a bit of room to do a cold spray repair, bringing that equipment to the repair instead of the equipment to a repair cell. But we also recognize that there's a lot of stuff we can repair shipboard, and if you look in the middle all the way to the left, you'll see the VRC Dragonfly. So what that is that's a hatchable cold spray machine that comes apart into 4 different pieces, and you can man carry it through a hatch on a submarine or on a surface ship. And Keith referred to us setting up the cold spray as a service. So what we're calling those is the cold spray pop-up cells. So the idea is oftentimes when you have a new technology and it becomes ready for fielding, you have what we call the innovation valley of death, where many good ideas go to die and don't get implemented. So one of the options is to provide that technology as a service. So NAVCO5 is contracting with VRC for a period of time, which is at least 2 years, where they'll pay VRC to provide cold spray as a service. This gives us an opportunity to prove out the repairs, as well as giving the shipyards time to develop their facilities, develop their air permitting, and jump through all the hoops in order to field this technology. We've found that it's taking quite a bit of time. It also gives the operators time to come up to speed on, becoming proficient with the cold spray. So the idea is to fund it for a period of time At the end of that period of time, if the vendor is doing well and wants to continue having that pop-up cell in that location, then they can basically continue, but they're funding it by themselves without the assistance of the NAVC-05 funding. And going up to the ADAPT, we did talk a little bit about the Raptor and the Dragonfly. Those were in the ADAPT phase not too long ago, but now they're available for adoption. The Dragonfly, I don't believe, is quite ready for sale yet. They're still working out some of the manufacturing aspects of that, but they should be ready hopefully by the end of this year. So one of the ADAPT applications we have is developing the handheld cold spray application. So currently we do cold spray with robotic because of the repeatability and the quality that the robots provide for us. Eventually we would like to do hand spray. So we'll still develop the QSPs using the robot, and then we'll do the hand spray application and compare the results. One of the other projects we're working on is developing powder qualities and packaging pipelines. The Army's done a great job of developing new powders, and we're working with Army and Solvus Global to develop more Navy-centric powders that work well for corrosion and such on the Navy vessels. So one of the things we came across when we decided we were going to set up the shipyards all the same way, there are test requirements that need to be met, and the testing protocols were interpreted a little differently. So we've had Penn State develop some common testing protocols. So when we do the testing, we're doing the testing all the same way. So the results, when we compare them, we're comparing apples to apples. One of the other projects that NAVC-05 is working on is similar to the Army's field hospital for cold spray, but it's a portable robot with a multi-purpose end effector that one of the tools that can be adapted is cold spray. So if you look middle of the page, you see a yellow robot. So we have a challenge with doing robotic repair shipboard with being able to have a robot that's small enough yet rigid enough to do the cold spray applications. So we're working with Penn State to develop a robot that you can carry shipboard with your Dragonfly, and we've adapted quite a few other tools to that multi-purpose end effector to do measuring, to do grinding, to do plasma blast, to do the cold spray repair and grinding, as well as doing your post-repair inspections. So up in the design phase, we're looking at cold spray for structural. What would it take to get us to a point where we can use cold spray for structural? That's a ways out yet, but we're developing the test criteria and looking at what would we need to improve in order to use it for structural repairs. And that's the same with cold spray for coatings. Currently, we're authorized to use cold spray for surface restoration. And as you can imagine, ships and submarines and seawater, there's quite a bit of a corrosion issue. So that's one of the areas we're looking at. How do we utilize cold spray for coatings? And when we spray the cold spray on there, how do we make sure that coating it with cold spray doesn't cause the component to erode itself a lot quicker? So there's a lot of R&D still that we're working on in that area. And like the Army, we've got, and I guess the Marines, all the services are forward deployed. So we're looking at, how do we get those expeditionary cold spray capabilities and developing the multi-purpose end effector, putting it in a box that we can ship all over the world. That is one of our opportunities to improve on. And then last of all, the autonomous cold spray repairers. We can put all the equipment in a box and send it halfway around the world, but I'm not sure our engineers would be happy if we stuck them in a box and shipped them with it. So in the future, you know, we can fly drones from halfway around the world. Why can't we have an engineer operate a system that's halfway around the world using augmented and virtual reality? So those are projects that we're looking into. Next slide, please.
Hey, Jeff.
Yes.
I'm gonna have to interrupt. We've got to leave a little room for Fred to provide some of his updates. So if you can give us a quick wrap.
Okay. So this slide I pretty much covered. Continue fielding cold spray technology. So what is next? Handheld cold spray applications, similar to what we do with welding. We used to do a lot of robotic welding, and now we're doing more handheld welding because we've proven the process and the coatings for wear and corrosion. So with structural repair, we're working with Penn State and the Army and Northeastern University on looking at helium recovery. The structural repair is going to require using helium, so how do we do that more efficiently and effectively? And we're also working with the universities for preparation of the repair site with laser ablation or plasma blast. And I will give Fred some time. Thank you.
Thank you, Jeff. As I can attest, when you start talking cold spray, not you, Jeff, but really any of our panelists, it's a field of passion, and it's hard to wrap up our comments rapidly. So thank you, Jeff, and I want to turn it over now to Fred Lancaster out of NavAir. All of our panelists are advocates for cold spray. I would call Fred my evangelist. He's been on the front lines, getting the word out there as a capability and a process that we really need to be putting in the hands of our users. So all of the biographies are on the website that announced this webinar. So rather than read the details out of Fred's biography, I'm going to turn it over to him so he can tell you all the reasons why cold spray is the best thing since yellow butter. Over to you, Fred.
All right, thank you, Keith, and really appreciate being here today invited to AeroDef. Next slide. So the reason why, looking back around early 2000s, the reason why Navy gotten into cold spray and found it appealing is we fly and we fight in some of the worst environmental areas, the sea, so surrounded by salt water, and of course our aircraft are made of things like magnesium and aluminum. So for years we've had to deal with the degradation caused by our operational environment. Then comes along cold spray. It's a thermal spray process, lower temperature. We can process using it manually, robotic, doing it on aircraft. So it really fits into the Navy's initiative, looking at affordability, maintainability, reliability, all those things that contribute to readiness, so we can repair and refurbish parts. Plus, it's affordable. Out of all thermal sprays, you can get into doing repairs on aircraft relatively cheap. Next slide. So just give you a snapshot of where we've been. The past 10 years, it's pretty much been primarily developed on working on developing the processes. So now, as we come into 2020, we've got about over a half dozen proven processes that we use for dimensional restoration. And, we've also have qualification from engineering that we ran through that we're now able to, anything as a blend and fill that is a dimensional restoration that we can use cold spray on. So the next, so the next generation of processes after that is going to be, as you see in the future 5 years, is going to be, let's look at structural repairs, and we're getting some headway into that currently. We're actually getting fatigue credit back, and those parties, all parties involved here in this meeting have participated in that in some way. But we also, we've standardized our processes, we've standardized our work practices, we've demonstrated a robotics on-aircraft system. We have systems all in all of our depots, and we're using them in production. So, next slide. So I want to quickly show you this. This is where we were back in about in 2008. Now, next slide. In 2019, you can see it's within less than 10 years, within just the Department of Defense, cold spray has really expanded, and this is showing you that we're expanding use in products. We're using it in acquisition programs, new programs. We're also using it heavily for refurbishment. Okay, next slide. So at our fleet readiness centers, we're fully equipped. We've been using systems, low pressure systems for years. You can see out at FRC Southwest, North Island, that's one of our main engineering facilities for cold spray. We've been using cold spray in production for over 8 years. We've especially been using the portable systems at all of our FRCs for on-aircraft applications, where we have the aircraft is torn down and they find some corrosion, and we take the equipment there, as you can see in the middle picture. The other innovative thing is we're morphing into is the one picture on the right is a on-aircraft robotic system that's trailer mounted that we can actually elicit repairs to the aircraft in place in the squadron level. Okay, next slide. So we really have, have applications. We find a lot of our applications today are in the low pressure. And just to give you an idea, these are some restored parts that we've done. These are actual production parts. So these are regularly being shown up on the production floor. We're refurbishing them and getting back into stock. The advantage of cold spray has been we can immediately get parts back rather than waiting for parts. A lot of times our parts are antiquated and we don't have a supplier. So cold spray has been able to help us to alleviate our some logistics issues and decrease our logistics footprint. So these are just parts we've done in the depots. We've more than paid back the investment that we've had for the past 18 years in cold spray just from production parts. So that's why we keep pursuing, we keep finding new avenues, and we keep moving us down to lower levels to where we're getting out to the squadrons. Okay, next slide. So what's our path ahead? Restoration of parts. So I'd call this, we want to go and for every squadron, every type of aircraft, to have cold spray have all the squadrons outfitted so they can repair corrosion on their aircraft with portable cold spray equipment. We call this like death by 1,000 cuts. If we can repair the metal with metal, then we will never get down to the structure. Enhancement. So we've been able to modify in some of our restorations we've been able to do. We've modified a current asset to actually last longer by putting down like for instance, a better wear coating, a less corrosion prone coating. And then repair, that's the next thing, is where we can actually add some fatigue credit back and some tensile strength back into the part. But one thing that we all think you've seen today here, especially with NAVC, is Training. Jeff said training is a big thing. We're all across the board. We're in agreement with that. We use things like augmented reality, process modeling, and getting training modules out there for our aircraft maintainers that are, they're the YouTube generation, and we need those type of training type of equipment and modules out there for them to use. Okay, and I think that's the last one. So I want to thank everybody. So I hopefully I got Keith back on time.
Fantastic. Thank you, Fred.
You're welcome.
And thank you to all the presenters. This has been a great overview of where DoD has come from and is going toward in our use of cold spray. We do have a few questions that have come up in the Q&A chat that I wanted to divert back to the panel. First question really goes to Jeff Campbell with NAVC, asking, Jim Fisher asks, are there any issues with using a portable system within a ship? And this comes from a powder overspray and then the safety and environmental concerns that come with that. I know you guys have been working a lot on addressing those. So Jeff, over to you to kind of tell us what we've learned in that realm. Over.
Yes, that could become a huge issue, and we're working with our partners to develop portable dust collectors as well as portable containments, and that is an issue we definitely have to overcome before getting approvals to be able to use the cold spray shipboard, as well as having changes to the process instructions that gives us that approval to do those repairs shipboard. So definitely don't want metal particles floating around in the air on a submarine and or a surface ship.
Awesome. Thank you so much, Jeff. Early on, we got a question about whether or not cold spray is a process that could be used to salvage in production items that may suffer a machining error, and specifically talking about like an undercut on a titanium forging. And we've provided some answers in the chat, but just to give voice to that, Bill Baker from the Marine Corps has already had a use case for that, and has been able to use cold spray to restore a part to a roundness specification before issuance and further machining. And then Isaac also weighed in that is absolutely a good use case for cold spray, and titanium is one of our metals that we are actively using and developing for that kind of purpose. And then so we've also had some questions about thermal spray versus cold spray. Isaac provided some great response detail, but just from a broad brush standpoint, why is cold spray better than thermal spray? I don't know that the answer is that one is better than the other, but that they have their conditions and their purposes. So that is, generally speaking, my bureaucratic answer, that there are places where cold spray will give you less impingement on the substrate and the thermal impacts of that. And then Isaac, you can expound on that, I guess, if you want to come off mute, just to talk about the ability to build up layers beyond what thermal spray can do. So Isaac, did you want to offer anything additional?
Yeah, sure. So I think the big difference is that thermal spray is usually just a very thin coating. And cold spray, there's no practical limit to how thick a deposit can be, because it's solid state. You can just keep building up layer by layer as thick as you want. So that allows you to use cold spray to make structural repairs, or restore machining damage, or use it for additive manufacturing. And as Keith mentioned, yeah, it depends on the application. There might be some applications where it makes more sense to use thermal spray, but you know, generally I think of cold spray as much more than just a coating technology. So yeah, that's it. Over.
Fantastic, thank you. So I believe that at this point we have exhausted the questions in the Q&A, and we are also running up against our time limit. So I would like to again thank AeroDef for the opportunity for the panel to come together and to relay the progress being made in this. Again, I just want to foot stomp that that the four panelists, they're the ones doing the real work out in the field, making cold spray a reality. I thank them for just all the engagement that I've been able to have in our teams as we've advanced the technology, and the real opportunity. I think Fred Lancaster pointed to this. It's a huge cost savings to be able to repair parts, but more than that, it is a time savings, and our ability to restore vehicles and aircraft and platforms back to service without relying on a turn-in and resupply in the DoD supply system can be a huge game changer for us. So with that, I want to turn it back over to Carl Mitroff for some closing remarks regarding this and upcoming SME events. Over.
Yeah, thank you, Keith. Thank you, everyone. Super informative, great discussion. I know we probably could have gone on for another hour digging deeper into this cold spray technology, but I really appreciate everyone investing their time. Special thanks to all of our guest speakers again for their expertise and technical insights on the technology. We appreciate the time and supporting the manufacturing community and our SME events. A very special thanks to all of our attendees who decided to spend an hour with us this afternoon. We'll be sending out a quick survey at the end of this webinar, and would appreciate any feedback that you have to help us create better content and better deliverables in the future. We will be recording, or we have recorded this presentation. The slides will be part of it, so that'll be part of the recording, and folks that asked that question in the Q&A. So that's kind of a quick summary. And then finally, our next webinar is on June 17th at 3 o'clock. And the satellite session is going to support developing and managing connected assets through IIoT. And registration for that webinar is currently open and live. And you can click on our AeroDef webpage for more information. Again, thanks everyone for your time, for your participation. Really appreciate it. Thank you, our guest, and enjoy the balance of your day. We'll see you next month. Bye-bye.